The sun. Why do we look at it so closely on the channel? Well, I assure you that there is a good reason, and the reason is cosmology. Welcome to the Daily Space Weather. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you from the Smash News Network, least busted name in news. Just bringing you the most detailed imagery of the sun and comprehensive space weather you'll find in the known universe. We study the sun in this level of detail because of cosmology. In the mid-1990s, I realized that there's a hole in cosmology, and that hole is a result of heliophysics. Until we understand how that star works, we will not have a comprehensive understanding of how the cores of distant galaxies work. We'll have a cosmology segment in this video also. So there's the full disk view in the past 24 hours. You will see a CME happening down here. Right about there. You see a little filamentary eruption. We'll show you a closer up image of that. We've got some groups that are setting here in the northwest. That makes the likelihood of large solar flares higher in those areas. We've got another new sunspot group that just rose this morning also. So here is your southwesterly limb. A great view of the southeast. By the way, there is additional space weather headed our way. So exciting stuff going on. Hopefully we'll get even better imagery of the aurora here over Lehigh Valley, Pennsylvania. We'll let that filament eruption play through one more time. And then we'll show new sunspots rising in the equatorial easterly region as well as the northeast. So we've been seeing sunspots at vastly different latitudes all throughout this solar cycle 25. And we've got a long way to go to solar maximum because we've still got fields oriented at the poles. We'll get to that later in our coronal hole update section. Here is yesterday plus today in SDO intensity gram. That sunspot in the north is indeed huge. It's multiple Earth diameters there. So like 3 Earth diameters there for that largest leading umbra. The trailing umbra has grown a little bit since yesterday, but it's mostly stable. In fact, most of these groups are mostly stable. Some more equatorial sunspots showing up here just east of center longitude. Here's your colorized magnetogram. Also yesterday plus today. And let's briefly take a look at Crescent Earth. But first, take a moment to press like and subscribe. If you've seen our Aurora videos, well, congratulations. We did see the Aurora over Pennsylvania, so there were green and pink Aurora here, so check those out if you haven't seen them. Thanks to our new subscribers, new Gold Smash Team members, etc. Now, many people complain about not getting notifications from certain big tech organizations, and so we've created a solution for that. It's called smashomash.com/smashteams. That's the official subscription services site of the channel. We still do have Patreon and PayPal if you want to donate to our causes that way. If you want to read about our mission, head to our forum at smashomash.com/forum/mission, where we'll tell you all about the mission. And the heck is happening? My screen is locked. All right. So smashomash.com/smashteam is where you can support the channel via a gold or silver membership. So thanks to our gold and silver Smash Team members especially. A gold membership features all kinds of things, like you can get an @smashomash.com email address if you like. Most first names are still available, so check that out. Become a gold member. And you can also see our latest major releases here without even signing up. So there's also a free bronze membership, which affords you some additional benefits. But if you don't even want to put in your email address, just click the posts page at smashomash.com/smashteam, and you'll be directed to our latest content. So make sure you log in if you are bronze, silver, or gold level. And once again, thanks to the Smash team for increasing the probability these videos will continue to exist, remain publicly visible, and free for all to view. Smashomash.com/Smash team. And let's get to Croissant Earth, because here's some fantastic imagery of Stromboli. Yeah, is it making you hungry? Well, it's making real estate investors hungry because it's creating some new real estate there with some effusive lava flows. Stromboli volcano there. And we've also got imagery of Popocatépetl. There you go. Popocatépetl there over central Mexico. A little bit of an ash plume being created there. And a great cloud there right around the summit. Let's see what else is erupting. So that is a new lava flow there, emerging from the North Crater at about 6:0600 local time yesterday. There was also a typical steep rise of volcanic tremor. Shivaluch is also erupting, producing a 13,000-foot plume of volcanic ash over the Kamchatka Peninsula. That's a flight level 130. Abiko, flight level 100. I think that's an uptick at Abiko, 10,000-foot ash plume. Sakurajima, 7,000-foot ash plume over Kyushu, Japan. Suwanosejima, flight level 070, as well as Suwanosejima explodes, flight level 070. It's a 7,000-foot ash plume. Dakono, 7,000-foot ash plume as Dakono explodes. Popocatépetl currently producing a 20,000-foot plume of volcanic ash, flight level 020. Don't decide to vacation in Mexico and pole vault that caldera. It could be unhealthful, and we need the views on YouTube. Also, Fuego in Guatemala exploding, flight level 145. It's a 14,500-foot plume of volcanic ash over Guatemala, headed down to Colombia. 22,000-foot ash plume produced by Nevado del Ruiz as Nevado del Ruiz explodes. It's a 22,000-foot ash plume. 21,000-foot ash plume over Sangay in Ecuador. Revenador, 14,000-foot ash plume as Revenador also explodes. Cotopaxi also exploding, flight level 220. It's a 22,000-foot ash plume. 25,000-foot ash plume over Sabancaya in Peru and Villarrica. Also showing up there on the list. Let's see. Ash eruptive pulses took place from the volcano summit yesterday. No indication on the ash plume size, just that it's something like 500 meters. Let's say a flight level 030. 3,000-foot ash plume over Villarrica, perhaps. Next, looking at seismicity. So this is the past 90 days of earthquake activity on planet Earth. In the past 24 hours have been fairly calm here. Not a lot of quakes and no very large quakes. We'll cite those that are over a 5 magnitude, such as this 5.3 near the coast of Nicaragua. That came in at 1846 yesterday evening, and thanks for leaving comments, Mike Bordages. We hope your clavicle is feeling back to 100%, maybe even 105%. As fractures do have a tendency to make bones stronger once they heal. Tajikistan also saw a 5.0. That was at 4:20 Universal Time this morning. Japan had a 5.2 at 11:12. And then less than an hour later, we had a 5.5 at the Carlsberg Ridge. There in the northwestern Indian Ocean. And let's get back to space. It's where the action is at. Space, a frontier. These are the voyages of that thing as we chase it through the galaxy. We'll talk about the interstellar space here momentarily. That's the past 24 hours in SDO 304 angstroms, one of the classic wavelengths, ionized helium. We've also got 193 angstroms added on there, and there is a huge filament fest going on. We've been naming filaments after living people, and there are a crazy number of filaments. So frankly, I've lost track, but I remember this one here. That's the Hillary Clinton filament, and that's the Kamala Harris filament over there. And you've got the Lex Friedman prominence down here, which is in the process of setting there in the southwest. So major filaments here, likelihood of coronal mass ejections, nearly 100%. So we'll cover coronal mass ejections here later. First, some solar stats. So the 10.7 centimeter radial flux, now up to 161 solar flux units. There is the 1-year graph from Solon.info. The black line is the radial flux. The red line is the sunspot number, and you may be noticing this blue line. That is the interplanetary magnetic field the post-dam AP, and check it out. Now, post-dam AP reaching up to 90. Yeah, 90. A major increase in the interplanetary magnetic field. Yet another indication that you're not seeing anything even remotely resembling a grand solar minimum. Let's take a look at the Space Weather Enthusiast dashboard as we are forecasting an additional significant geomagnetic storm to arrive late tonight. Up to about midday tomorrow, we're expecting the onset. That should last throughout a significant portion of tomorrow, so we're sort of refuting this forecast here from NOAA. We are expecting an additional CME impact, and this one is going to be even more significant, so don't be surprised to see a KP8. A KP8 geomagnetic storm. That's the forecast. Late tonight through midday tomorrow, we're expecting a major CME impact, more significant than the last one. So let's see what the NOAA Enlil spiral is looking like here. And basically what they modeled here is that it's going to have already arrived. And keep in mind there is a coronal hole high-speed stream as well mixed in there, so that doesn't help to clarify the waters at all. We've had some of I believe the highest, actually, solar wind velocities measured so far during solar cycle 25, reaching up to nearly 900 kilometers per second. That second CME, again, I believe it is more earthly directed than the initial one. We're hoping for clear skies tonight in the hopes of getting more auroral imagery. So here's NASA's model. NASA's different Enlil spiral there. And once again, it looks like that CME is modeled a little bit farther off to the west than we really expect. But anyway, it's showing another glancing blow here. We're expecting a more direct hit than that. But hey, science, it's all about figuring out who's right and then moving on and not trying to gaslight. So there's your planetary K index, a measurement of global geomagnetism over the past 3 days. And yeah, we reached a KP7. I'll forecast a KP 7.67. So maybe we won't reach 8, but I'm expecting a slightly higher geomagnetic storm than the last one, again, because the other factors are pretty similar here. So we've also got a very high electron flux. We're expecting a major electron storm. We'll cover that later in the video. First, let's look at some more magnetic data. Here's Earth's magnetic moment from space for the past 4 hours. And of course, when we say Earth is croissant-shaped, it's because we're talking about Earth's magnetic moment from space as a solar proton typically experiences it. And not exactly sure what's going on there. It's showing quite a small magnetosphere there for the past 4 hours. Looks like there might be some errors in the data. I don't really believe that. Here is ground magnetic perturbations map for the past 4 hours. Don't expect this to be any more accurate. If the last one was off, this one's going to be off as well. They're both based on the Space Weather Modeling Framework. If you want to read about what that is, click on the Details tab at the bottom of the Geospace Magnetosphere or Ground Magnetic Perturbations Movies pages. It'll link you to the Space Weather Modeling Framework where you can download the data sets yourself if you want to analyze them. Anyway, that's the last 4 hours. Now heading out to Lagrangian Point 1, the location of the ACE, the Discover, the SOHO, to look at the real-time solar wind. So we're seeing some error bars here that looks like they've now cleared up. And the current situation is a subsiding space weather environment there. Current conditions are still quite elevated here at over 620 kilometers per second for the solar wind speed. Solar wind density there quite diffuse at only 2.16 protons per cubic centimeter. So yeah, we've got a coronal hole high-speed stream here currently going on. And the top pane there, you can see the BZ has just gone into negative territory once again. If that stays negative, we can expect to see additional geomagnetic unrest or storm conditions. So we'll be monitoring that and, again, expecting a more significant coronal mass ejection impact tonight up to maybe noontime tomorrow. Here are our GOES magnetometers. And you see very sawtooth readings there, as we typically do during coronal hole high-speed streams and CME impacts for that matter. So that's the past 3 days there, the measurements by the GOES 16 and GOES 18. Next, we'll look at the heliospheric current sheet, as Earth is right in the middle of the south solar magnetic pole. So there's a great situation there. We're right in the middle of the south solar magnetic pole. North pole shown here in green, south pole shown here in red. The plasma that comes out of the sun is polar. And the current plasma Earth is seeing is solidly south pole oriented. Let's take a look at the line of sight field plot next. There you can see the sun's B field depicted in blue. The B field is the field going through the magnet. North solar polar field depicted in green, south in red, which brings us to coronal holes. As the solar cycles progress, we watch the solar polar fields, which are fixated at the poles at solar minimum. They slowly migrate to the opposite pole. So the south pole will be fixed there, and at the end of solar cycle 25, it'll be at the north. We'll have red magnetism up here, and we'll have green magnetism down here. That'll be our next solar minimum. And we're still waiting for the solar polar fields to evacuate their respective poles. An indication we've got a long time to reach solar maximum. So all of those doomsayer, naysayer, confused channels that keep telling you that they just keep chanting grand solar minimum, grand solar minimum, grand solar minimum, as if that's going to make it come true through some sort of dogmatic, magical prayer thought. I don't know what the reasoning is behind it, but it's just ridiculous. It's clearly not anything even slightly close to resembling a grand solar minimum. Tamitha Skov seems to think that solar cycle 25 will be a more significant solar cycle than solar cycle 23. Yeah, not only bigger than 24, but bigger than 23 also. Let's take a look at coronal holes here, since they're such a great indicator of the solar cycle progress. And let's go back here for a minute and bring up the latest frame. Check it out. Right down there at the south heliographic pole, we've got a south pole oriented coronal hole. So this one's south, this one's south, and this one's south. Also, this one is south. So this magnetism down here needs to leave the south heliographic pole and head to the north, and vice versa with the north pole. That's not even happened yet. It could happen quite suddenly, but in any case, at the moment, we've got a long way to go. We can expect to see no real fixated magnetism at the poles during solar maximum. All the coronal holes will be somewhere in the mid-latitudes to the equatorial region. At the moment, that's not what we see. Here's a south pole-oriented coronal hole right at the south heliographic pole. Anyway, that's your coronal holes report. Let's move on to sunspots next. And we'll have one more named group, this group up here. And it's already looking like it's producing some activity. So I suspect that it's beta gamma class at least. So far, we only see one umbra. I suspect there are probably south pole trailing umbra there as well. It's a little bit too early to tell, or at least it was when we did show prep. Let's take a look at sunspots with the SDO continuum plus the .304 angstroms wavelength. I think I must have forgotten to put that in the tabs. We had nearly 100 tabs open a couple of days ago there. I think yesterday we only had like 90 tabs open. Anyway, that's the past 24 hours, SDO 304 angstroms plus SDO continuum. Let's subtract the 304 angstroms. If that sunspot stays that complex as it approaches the western limb, the likelihood of it producing major flares is just this side of 100%. Also, this group down here could produce major flares as it sets. Next, let's talk about solar flares and energetic particles. So let me just do another demonstration because I know it's commonly misunderstood, the difference between solar flares and coronal mass ejections. So let's just explain this one more time. Take a flashlight and shine a flashlight in your face like this. Right? There you go. That is light. Solar flares are light in the form of X-rays. Coronal mass ejections are a little different. Turn on a fan. You'll feel the fan blowing in your face? You feel that wind? That is like a coronal mass ejection, and the light from your flashlight is like a solar flare. They are completely different phenomenon. One is light, one is gas, and so don't get them confused. Solar flares are photons. Coronal mass ejections are protons. These are relativistic protons that get stuck in Earth's field-aligned currents when they show up. These showed up only about a half an hour after an M-class flare. And they are now subsiding. We're back to a baseline level. We just came back to the baseline level here. So the polar radial blackouts are now done. Let's take a look at flares. So these dips in the X-ray flux, those are actually lunar eclipses at the GOES 16, or in this case, the GOES 18. We've actually seen a dip here in X-ray flux. So we're going to see this come up a little bit. Probably the radio flux is going to come up a little bit as well here. Because, again, we've got a fairly active sunspot rising there in the northeast. So let's take a look at the last 24 hours and 171 plus 131 angstroms. Great couple of wavelengths there. And we'll subtract the 171 angstroms and just show 131 by itself. Consumer tip, use 131 and 94 angstroms to get the most temporally detailed images. 94 and 131 angstroms from SDO take 10 images per minute instead of only 2. They're specifically designed to view solar flare activity. That's 94 angstroms for the past 24 hours. Again, most of our HelioViewer videos are 24 hours on our daily space weather videos. Sometimes we zoom in into a specific period of time and slow things down to show specific activity. See our previous daily space weather videos for the most detailed imagery of the sun you'll find anywhere on the internet. Now, if you want to support the channel, one of the ways you can do so is through merch. Now, we've got some merch here, which is of varying degrees of seriousness. Some of these are designed to start conversations, and some of them are designed to end conversations. So make sure you forgive, remember, and hold accountable, because holding a grudge is like consuming poison and expecting the other person to die. And remember, folks, that our finest days lie ahead. So don't pole vault the caldera. If you're going on a volcanic vacation, don't do what Steve Stimpak used to do and pole vault volcanic calderae. It could be unhealthful. Now, of course, Steve Stimpak died in the late 60s in a ping pong accident, which was a tragedy. He was training for the U.S. Olympic ping pong team when he was hit by a bus. It came right through the wall. Anyway, check out the gear. The merch store is fresh. We just put up 3 new designs with Do the Math, featuring Deneb, the Sun, and Sagittarius A Star, the Milky Way galactic core. In the meantime, no matter how things get, don't worry, they can get worse, certainly, especially if additional terrible decisions get made by bureaucrats who can't even get out of their own way. However, our finest days lie ahead. So keep that in mind. And again, please do not pole vault the caldera. We need the views on YouTube. Press the like button, press share, leave a comment, etc., and let's orient ourselves to the realm of cosmology. Now, if you open up Plasmascape, plasmascape.com. It's actually plasmascape.com/plasmascape_007. You'll find a link at plasmascape.com to get to this imagery. So when you first click it, that's what you'll see. It's a zoomed out view of the solar system. That purple line there, that's Pluto's orbit. And if you press the A button, it's going to show you a series of tabs. Now, the tab we're going to be focusing on here in a lot of ways is just a minute here, the solar apex, okay? The solar apex is the direction that the sun is moving throughout space. So the 1, 2, 3, 4, 5, those are different views. If you click on one, it's going to bring you all the way into the solar system. There you go. There's the view of the inner solar system there. This is Mercury, Venus, Earth, Mars, Jupiter. There's Saturn. There's Uranus out there. So that's the closest view. If you zoom out to 2, that's like the default view. You're kind of looking at the solar system from a distance. So let's take a look at the solar apex here. So there's the direction that the sun is moving, okay? The sun is actually moving toward Deneb, right there in the constellation Cygnus. And if we zoom out further, there's the heliosphere, depicted as a sphere. Now, of course, many of us believe that the heliosphere is probably croissant-shaped also. But let's just take a look at this, the solar apex here. Again, there's the direction of the sun's motion as it moves toward Deneb, roughly. And if we zoom out to level 4, we'll actually start to see the interstellar space. So this is the filamentary material that surrounds the solar system. And if you move out to level 5, it'll show the interstellar chimney. So this is the sort of the local structure. If you zoom way out, you'll see this hourglass-shaped structure. It's a giant tube-like filament. Again, there's the solar apex, and you can see it's kind of like moving toward the wall of that filament. And the galactic center would kind of be off to the sort of behind you, like to the left. And that is the environment in which the sun is located. So that's the local interstellar environment. We call it the local interstellar chimney. That's sort of the structure of the space directly around the sun. As you can see, it's nothing like the heliosphere. The galaxy is very big. There's a lot of stuff in it, and that stuff is very far apart. Let's move on to more orientation here. Here's what's going on overhead at the moment. If you're up before dawn, you might see Saturn and Mercury. And if you're viewing the sky just after sunset, you might see Jupiter and Venus, as they are chasing the sun right now. You can see Jupiter and Venus very close together in the sky. The third and fifth brightest object in the sky right now, Jupiter and Venus. They're available in the evening sky just after sunset. So thanks for leaving a comment, Jackie2. I have not seen that clip. I have no idea what that is, and I can't really view it during the video. I will check it out later. Maybe email us about that, as I can't really interrupt the live stream to visit your links. Anyway, here's what's going on in the solar system. We'll advance this 1 week as we're interested in a forecast. So here we go. Here's where things will be in a week. We'll be just at the full moon there on the 7th. Please keep in mind this imagery is not to scale. Next, looking at coronal mass ejections via our George Mason University coronagraphs. So that is yesterday's imagery. That's 95 frames from yesterday. Some relativistic particles there showing up, surprisingly, actually, despite no large flares. You'll see right there, you see a bunch of rectangles show up, an indication that high speed, significant percentage of light speed particles are striking the aperture. Here is today's images, an additional 37 images. And you're probably interested if there are any other additional CMEs on the way. Let's take a look at some more images here. From Stereo A, which is this red sphere, and also the Soho-Lasco C3, which is in between the Earth and Sun at Lagrangian point 1. So we'll just let these play through here. We do not see any other, based on the available data here, indications that there are additional Earth-directed coronal mass ejections. Just expect a major one tonight. And again, fingers crossed here for clear skies over Lehigh Valley, Pennsylvania. We will go out several times checking for aurora if there is likelihood of them being there. So we're super stoked about it. I mean, the first time we ever captured aurora on imagery was just a couple of days ago. So exciting stuff. Here's the past 24 hours. Soho-Lasco C2, C3, and SDO 304 angstroms. So again, some CMEs happening there. They do not appear to be earthly directed. Here we'll zoom in a little bit closer. You will see that filament in the southeast blasting off there. And it's always great when you can actually see a filament leaving the Earth-facing portion of the solar disk and then being represented in the Lasco C2 and C3. At this point, Yeah, those are not earthly directed coronal mass ejections. And let's move on to filaments. So now we're at El Teide, Spain's ground-based solar observatory. And the filament fest continues. What can I say? I mean, look at the number of filaments. It's not as high as it was a couple of days ago. But there are still a lot of dark absorption features here on the solar disk portion and a lot of prominences. You can see a prominence there, a prominence there, prominence, prominence, prominence. That's the Peter Gabriel prominence up there, I believe. Anyway, lots of filaments. Likelihood of coronal mass ejection is very high. And once again, folks, I would remind you that we don't need to see sunspots or solar flares to see coronal mass ejections. We were covering them. We figured out how to predict coronal mass ejections around solar minimum, although it didn't really do anything to increase viewership of the channel. So since if it don't make dollars, it don't make sense, we just stopped doing it. Yeah, it was another thing discovered by accident. So anyway, follow us on Twitter, as you'll see some information you won't see anywhere else, like the link to our Hemp Lucid free mushroom gummies giveaway. Yeah, we're trying to increase our Twitter followers. We're pushing 400 here, which is, wow, big deal. We've only had an account since 2019, over 19,000 tweets, daily original content, and our own web ring, including our own servers. Twitter, the shadow bans continue. Here's what you'll see if you click that link. You'll see that link to the free mushroom gummies. So if you want some free samples, if you want to try out mushroom gummies for focus, stress, sleep, etc., check out the link. Here's another 24-hour video of the closest star, and thanks for stargazing with us here at the Smash News Network, least busted name in news. That's 193 plus 171 angstroms to show the lower corona. That's the 171 angstroms part. And the extended corona, that's the 193 angstroms part. And since we've got a crown filament happening down here, check it out. We've got this filament down here, right on the edge of this coronal hole. Now, keep in mind that coronal hole is a radio jet. There are high-speed protons blasting out of that. It is like a stellar low-pressure system. The difference between low-pressure systems on stars and on Earth is that low-pressure systems on stars blast material out into the greater solar system. On Earth, they cause precipitation. A little different, but anyway, stars are pretty rowdy compared to planets. So that's the past couple of hours from the GO 16 SUVI. Let's just zoom out and show the full disk. And it's time to chew bubblegum and do bonus features, and we're all out of bubblegum. Our first bonus feature is charging hazards, and we've got some minor charging hazards here of the surface charging variety over the Central Pacific Ocean here and over parts of Mexico and Central America. Those are caused by low-energy electrons on the surfaces of satellite, hence surface charging. Anyway, moving on to our electron flux, and we're pushing warning levels here, and we're expecting a major electron storm here. So this could translate to communications errors and so on. So we will be keeping you informed of this in our coming videos. There is a forecast for a major electron storm. At the moment, we're just pushing warning levels here. Here's the forecast, and check it out. The forecast practically off the graph here. So expecting very, very high levels of electron flux coming, coupled with an incoming coronal mass ejection, and that could affect how things operate indeed, especially in places like the outer Van Allen belt, as if there are that many relativistic electrons out there, we can expect some major acceleration and a puffing out of the outer Van Allen belt, actually. Here's the one-year graph to put it in context. And you can see, let's see, 10 to the 9th. The forecast is for the electron flux to be way up here, which would be the highest levels in the entire year, which is what 1 year is what's depicted on that graph there. You can find that yourself, if you like, at solon.info. We'll also show the portion of the ionosphere where that's measured, the F layer, which is at about 300 kilometers of altitude. Feel free to pause the video on this frame if you're not familiar with chemical concentrations, temperatures, and electromagnetic radiation penetration of the Earth's layers. So here's that one slice, the 300-kilometer layer, the F layer of the ionosphere, the vibrational frequency therein, and we're seeing massive global-scale low-frequency anomalies. It might not be obvious to you from this view. That's why we typically show the anomalygram as well. So that's the previous day showing 2 hours per second vibrational frequency, millions of vibrations per second. And here's the anomalygram showing anomaly in megahertz from a 30-day median. And check out the low-frequency anomalies. Those are global scale low-frequency anomalies as plasma filters in to lower and lower layers of Earth's magnetosphere, or Earth's atmospheric layers, we'll say. So that's a sort of a lagging effect of the coronal mass ejection impact that we saw, along with the coronal hole high-speed stream, which actually continues, but mainly from the CME and from some relativistic particles there. So major low-frequency anomalies happening in the ionosphere. We'll bring it to the latest image here and move on to the total electron content. There's the latest image, 12:45 Universal Time. Total electron content depicts the free electrons between your GPS satellite and your handset. Those free electrons can cause signal refraction. So, of course, the inner Van Allen belt, that's going to be at its most dense right underneath the sun. So around the equator at noontime is where you see the most GPS errors. Let's see what's going on. And we're seeing things fairly organized here. So typically, as we see higher and higher levels of electron flux, we typically see more and more organized total electron contents. Also, please realize that when a CME impact happens, it could certainly create some anomalies here. But at the moment, things looking pretty normal there. GPS errors not too extraordinary. And let's take a look at the latest high-res images of the closest star here before we move to meteorology. So we're zooming in closer and closer to Earth. Here's your latest colorized magnetogram and latest SDO intensitygram. Let's take a look at this newest sunspot. And it is beta gamma class, because right here you've got a South Pole umbra. So this umbra right here, this one is south, this one is north, making it at least a beta gamma class sunspot group. Not really too surprising there, as it has already been producing a little bit of activity. All eyes on the northwestern limb, rather. That group is remaining beta gamma delta class. And check it out, there's a really cool light bridge there and a neat curve going across the umbra. That's about 3 Earth diameters there, that umbra. Fantastic imagery there from SDO. That sunspot is major. So here's your full disk rock back. We may have some active regions forming down here also. I see a little umbra there poking through. Anyway, that's the situation, and let's get to our meteorology station. So we're looking at the equatorial Pacific Ocean here in terms of ocean currents and sea surface temperature anomaly, and we've seen these currents change. Okay, these currents were primarily just crossing the ocean from east to west. Now we see turbulence in those currents, and we also see warmer water mixed in. So we've seen anomalously cold water here for an extended period of time. That looks like it's breaking down now, an indication that La Nina is ending. Anyway, that's the current situation for sea surface temperatures and ocean currents. Many of you may be interested in the Gulf Stream, since many hacky YouTube channels might be telling you that it's going to shut down and we're going to have a year without a summer in the Northern Hemisphere. But the Gulf Stream is still making it to warm up Iceland and Ireland. So, whoops, apparently not. And there's actually lots of anomalously warm water mixed in there, more so than cold. And again, the Gulf Stream is still making it to Europe. So the northern hemisphere is not going to freeze, not anytime soon. Got a bunch of warm water in the southern Atlantic. Also the southern Indian Ocean there, where it borders the Southern Ocean, featuring some anomalously warm water. Anomalously cold water around Indonesia there. There's the rest of the Pacific, the western portion. Check it out, Kamchatka and Japan. Or actually, just Japan. Kamchatka's got pretty normal water temperatures. Japan is in hot water. Not just because of inflation. Just kidding, folks. It's mainly because of inflation. Anyway, here are the... And you know, another thing to understand, folks, is that I am an economics wonk. So part of the reason why we make these videos is because solar forecasting impacts economics. Because, well, the sun, you know, it's the ultimate cyclical. So you may be interested in cyclical stocks like paper stocks or something like that. Boring cyclical stocks. Well, cyclical is indeed space weather. And it helps for people to understand how to forecast it. So we hope you're able to forecast your earthly weather and maybe even your space weather if you've been tuning in for a while. Here are the surface winds of the eastern world. And like sands through the hourglass of time, these are the jet streams of the eastern world's lives. Doubled up jet stream over the northwestern Pacific. And some turbulence in the central Pacific there. Of course, the jet stream pumping more and more moisture into California. It's getting heavy. It's about to sink into the ocean, folks. It's going to break off the North American continent and slide right into the Pacific Ocean. I know many of you are hoping for this. I'm not particularly hoping for it, but whatever. Those are the jet streams over the western world. Here are the surface winds. A double low there in the North Atlantic. Surface winds of the central world are depicted here. And there are your jet streams depicted by the 250 hectopascal winds. And let's blast through the rest of the video here. First, visit our links. If you haven't seen the Hemp Lucid shop, if you're in the market for things like CBDs, by the way, the body balms are fantastic. I've been using that a little bit more. So check those out. You can find a link below the video and save some cash by entering the promo code SMASHOMASH on checkout. Promo code SMASHOMASH on checkout. Speaking of SMASHOMASH, SMASHOMASH.com is the official website of this channel. So visit that and welcome to the Neo Renaissance. You can find all kinds of links. Hit us up on social media. Tell your friends and foes about us. Permanent link to the Discord chat, to this Twitch channel, and lots more like Twitter. And let's get to meteorology here, as we are now looking at the water vapor over the western world. So there's your water vapor satellite, part of the NASA GOES Interactive Weather Satellite Suite. Moon shadow there at the bottom, I think. Moon shadow. So there's the water vapor scenario over the western world as we focus in closer and closer on the U.S. Let's take a look at weather.gov. Lots of weather warnings there, mainly of the wintry variety. As winter trudges on, and the groundhog, Puxatawny Phil, was proven correct. It looked like an early spring, but not anymore. There's snow on the ground in Lehigh Valley, Pennsylvania. If your location is lit, click your location on weather.gov, and here comes some forecast. This is temperature anomaly based on the GFS model for the next 72 hours. 72-hour GFS temperature anomaly forecast in degrees Celsius. So it's going to be largely below temperature, below average there, west of the Rockies, and above average temperatures east of the Rockies. We'll also show pressure and precipitation for that same model, the GFS 72-hour forecast. Some strong storms here expected to kick up in Arkansas. Also, Tennessee is going to get kaplastered with heavy rains and perhaps some severe thunderstorms causing things like damaging wind and hail, so check that out. And To Jackie 2, yes, we have a Discord channel. If you visit smashamash.com, you'll get a permanent invite link to the Discord channel. You need an invite to join a Discord channel, and there's a permanent one at smashamash.com. Here's our GFS positive accumulated snow depth change in inches based on the same model, the GFS 72-hour. And still another pushing 3 feet of snow forecasted for sections of California. As if it's not snowy enough in the eastern part of the state there. Yowzers. Shout out to Smash Staff's mom. It's a little bit snowy. So additional snows there forecasted for the next 72 hours. And let's move on here as we don't want the video to be too lengthy. This is the European forecast for the next 3 days of new snow. So again, there's the GFS model for the next 3 days. And there is the Euro model. Pretty similar, as we expect more snow here to fall over Lehigh Valley, Pennsylvania. Continuing on to our NASA Goes Lightning Mapper. Got some significant storms there in the North Atlantic, also off the coast of North Carolina, between North Carolina and Bermuda, some severe thunderstorms. And we'll see if we have any terrestrial strikes. Next time you hear thunder, check out lightningmaps.org. You could convince the natives that you're Zeus or something like that. No terrestrial strikes in the U.S. at the moment, but some significant lightning there in the North Atlantic. Next, our U.S. Doppler radar map. There are the full 50 states. And thanks for joining the Discord chat, Jackie 2. Here is the lower 48 Doppler radar. Here's the lower 48 clouds and fog. That's 3.9 nanometer infrared radiation, by the way. And there is the water vapor. Hopefully that clears things up. Hopefully you're not consuming too much nonsense on YouTube. Here's your recap. These ground-based systems show vertical motion in the air column. These space-based systems show infrared radiation emitted by clouds and fog at 3.9 nanometers. And this space-based system shows water vapor, all of it. Not just clouds and fog, but all of the water vapor. In other words, dry is depicted in orange and yellow, wet is depicted in blue to pink, and that is where we will close things out. Thanks for tuning into the Smash News Network, least busted name of news. We're frankly surprised that you're aware that the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.